Oh, that's wonderful. Thank you, Coco. Well, welcome back, everybody. It's so nice to have you all with us again. I hope everybody's well this Tuesday afternoon. We're kind of most of the way through this course on geometry. And yeah, I just want to encourage you again. Coco and I are here to help you. We're not here to judge. No one's here to judge you. We're just here to try and help and try and make these concepts a little bit more accessible. So please ask us lots of questions. You can ask Coco, you can ask me, you can put something in the chat. We really do want you to interact with us and ask as many questions as you need to. And please don't for 1 minute think that your question is stupid. You know, if you're asking it, there's chances are somebody else is probably thinking the same thing and is maybe too shy to say anything. All right, so what we've covered up September, there we go. Cool, go for it, September.
I'm so sorry to go ahead.
No, man, of course.
So basically, prop and theorem and converse prop and theorem are two separate things. So it's not the same thing. It's just two different things.
Yes, they are, September. They are two different things, but they are the exact opposites of one another, and that's, I beg your pardon, that's what they mean in maths and in English by the word converse. All right, so a converse theorem is the exact opposite of a theorem. So you would have come across converse theorems last year in grade 11. So for example, when you want to prove that a quad is cyclic, you always have to say converse opposite angles of a cyclic quad are supplementary, or converse exterior angle of a cyclic quad. So what a converse does is it says, as I was saying, it says the exact opposite. So it tells us that if a line divides two sides of a triangle into the same proportions, then that line must be parallel to the third side. Okay, can you see, Matrix, how that's the complete opposite of proportionality intercept theorem? Okay, proportionality intercept theorem says to us, if there is a line that is parallel to the third side of a triangle, then that line cuts the two sides into the same proportion. Converse proportionality intercept theorem says to us, if we have a line that divides two sides of a triangle into the same proportion, then that line must be parallel to the third side. So it's the exact opposite. All right, so in other words, what we would want to do, or what we would need to do here, is we would need to know something about the proportions. Okay, so if they told us, for example, like you can see here in the middle of the page, if they had told us that ax over xb equals ay over yc, we are then allowed to conclude that xy over bc is, sorry, xy is parallel to BC, and our reason for this is converse proportional intercept theorem. You can abbreviate it to this, okay? And because you are proving that the lines are parallel, you don't state them, all right? So you can just write this. You can write converse proportionality intercept theorem, and that's enough, okay? All right. So let's have a look at an example about how this works. All right. It's actually very easy. And I don't know why, but like every year that I've been teaching matric, I've always found that matrics have struggled with this particular section. And it's not that I can't understand why, but it's not actually that difficult. And every time I teach it, I want to try and make it accessible to my students, but somehow people just seem to struggle with it. And it's actually really not that challenging. Anyway, let's go through it. Okay, so they've told us here that P and Q lie on sides XY and XZ respectively of triangle XYZ. Now they give us some lengths. They tell us, matrix, that XP is 18 centimeters. They tell us that PY is 10. They tell us that XQ is 22,5. And they tell us that QZ is 12,5. They want us to prove that PQ over YZ, sorry, PQ is parallel to YZ. Now, the biggest mistake that students make in a section like this is that they start this off the way that they start off when they're working with proportionality intercept theorem. You can't do that because you are trying to, you can't start off by stating as a fact what it is that you're trying to prove is true. Does that make sense? You can't use what you're trying to prove as your first statement, right? So you have to, like, for example, let's say I was accused of murder, God forbid, all right? My attorney or the prosecuting attorney can't say Lee is guilty of murder because she's guilty. I'm not guilty of murder because I'm guilty. I'm guilty of murder because my fingerprints were on the weapon, or I was in the right place at the right time to have committed the murder, or the person's blood was found on my body. That's why I'm guilty. I'm guilty for other reasons. I'm not guilty because I'm guilty. So it's very important that we don't use what we're trying to prove as a reason for trying to prove it, if you understand what I'm getting at. Okay, so in other words, we cannot start off by writing xp over py equals xq over qz. You're not going to get any marks, okay, because that's what we are trying to prove, right? So what we need to do is we need to show that these lines have been cut into the same proportions, and we do it like this, okay? xp over py is 18 over 10. Good. Now you can simplify that. We divide them both by 2. That would give us 9 over 2. Now separately, we work out what xq over qz is equal to. Okay, and that's going to be equal to 22.5 over 12.5. Now, if you guys pop that into your calculator, you will see that 22.5 divided by 12.5 is also 9 over 2. So now what I'm allowed to do is this. Let me just move this down and out the way. So I want to continue with what it is that I'm saying. Let's just delete that. Okay, so now we are allowed to conclude because they are equal to the same thing, to the same value.
It 9 over 5?
Is it 9 over 5? Sorry. Of course, sorry. 10 divided by 2 is not 2, is it? Thank you. 9 over 5, there we go. So because they're equal to the same thing, the conclusion is now that they must be equal to one another. So now we may conclude, therefore, xp over py is xq over qz. So this is now our conclusion, not our opening statement. And now we must say, therefore, pq is parallel to yz. And our reason for this is because the corresponding sides, sorry, I'm talking about similarity now, yeah. Converse proportionality intercept theorem. Okay, so that's how we set it out if we want to prove that lines are parallel. Does that make sense to everybody? Are there any questions you'd like to ask me? Sure, we're all good.
Yes, ma'am.
Okay, thank you. Thank you. Okay, so please, yeah, interrupt me if you want to ask me anything. I really don't mind. That's why we're here. All right, so now we've got a traffic light. Okay, I think that everybody should be able to do number 1 on their own. So I'm going to give you, Coco and I will give you 5 minutes to try number 1. You can certainly get started with number 2 if you want to, but then we're going to do number 2 together. So give number 1 a try. And when you're done, you can say done in the chat. And if you want to ask any questions along the way, then please ask us. Okay, off you go, Matrix.
Ma'am, please zoom in a little bit in it.
With pleasure. I'll make it bigger for you. How's that? Wow, Kanyisile, you're already done. That's amazing. Okay, so tell you what, Kanyisile, go on to number 2 and see if you can do do that one on your own as well. Oh, and Cassandra's also done. Well done. That's fine, Cassandra. Go on to the next one if you think that you're done. Oh, wow, you guys didn't even need 5 minutes. That was super quick. Well done. Okay, try number 2 if you're finished. Okay, yes, September.
Sorry, I raised my hand by mistake.
Oh, okay, no worries. Cool, everybody. Well done. Nice. Okay, so what we should have had, certainly as far as number 1 is concerned, is we should have had dA over AE would be equal to 14 over 6, which is going to give us 7 over divide by 2, which would give us 7 over 3. Then we would have dB over BF, and that would be equal to 21 over 9. Divide by 3. Then we must conclude that dA over AE equals dB over BF. Therefore, AB parallel to EF, converse proportionality intercept theorem. Okay, so yeah, we often test that at my school. I just want to answer a question, Nicole. Is there another reason that can be used when calculating 1? No, Nicole. Definitely not. So we don't know anything about angles in this situation. The only other way that we could prove that lines are parallel is if, for example, let's say you knew that this angle over here was equal to that angle over there. Then you could prove that AB was parallel to EF because corresponding angles are equal, for example. But we don't know anything about the angles. So no, we would only be able to work with the sides in this instance. And that's why it would have to be converse proportionality intercept theorem. Okay, no problem, with pleasure. All right, so now let's have, is everybody okay with that? I think that's fairly straightforward. It's exactly what we've done. So I'm going to rub that out and just clear the space here and we can have a look at number 2. Cassandra, no. Remember, we are proving that lines are parallel. So we can't say proportionality intercept theorem, because if we're saying proportionality intercept theorem, they've told us that the lines are parallel, which means the sides are cut into proportion. So if we're trying to prove that the lines are parallel, we can't say proportionality intercept theorem. It's got to be the converse of that because it's proving the opposite. Okay, so proportionality intercept theorem is there. Your given lines are parallel, you deduce that the sides are in proportion. Okay, then you use proportionality intercept theorem as a reason, and you need to state the parallel lines. Here, the diagram or the picture does not come with parallel lines. You are proving they are parallel. Okay, so we would do that by showing that the sides have been cut into the same proportions. then concluding that the lines, the proportions are equal to one another, and then that the lines were parallel, and then converse proportionality, intercept theorem. Okay, it's sometimes a difficult thing for a lot of students to understand when you're trying to prove a converse or an opposite of what it is that you've already got. So please just continue to ask questions. All right, let's have a look at the second one. I don't know if anybody managed to have a go. Yes, so can you see there, they are very strict in matric marking about your reasons. You'll see when you look at your NSC exams. Well done, Ketelwazi. We'll have a look now, see if we hopefully we got the same answers. Yes, can you see there, they're very strict about how they mark. Well, they're obviously strict about how they mark everything, but when it comes to geometry, you'll see normally there's a big heading that says for questions 9, 10, and 11, or whatever it is of paper 2, reasons must be given. If reasons are not given, then you're going to end up losing marks. So yes, you would get marked down. All right, you would get a mark taken away. All right, and the other thing that they will also do with you, while we're just on it, is that if you are working with proportionality intercept theorem and you don't name the parallel lines, they'll take a mark away from you as well. Okay, so just be aware of that. If you use proportionality intercept theorem, then you've got to state that the lines are parallel. Okay, so they are strict on that. Okay, well, Ketelwazi says that she's finished the second one, so that's really good to see. How did you set yours out, Ketelwazi? You want to tell us? What did you write?
Good day, ma'am.
Oh, sorry. Hi. I called you she.
Or
he. Sorry, I beg your pardon.
What I did, ma'am, is that obviously OK and OE are equal because they are both the radiuses. So
Correct.
we now have equal sides on both sides of this triangle, and we were given that the angle H and angle C are equal, and we know that in an isosceles triangle we have 2 equal angles or 2 equal sides. So what I could gather is that since H and C are equal, that means we obviously have an isosceles triangle, meaning we have to have 2 equal sides as well. So I took it upon myself to make OC equal to OH, and then I used the property theorem, making OK equal to OC. So instead of making it OK and KC, I made it OK and OC is equal to OE and OH.
That's fine. That's absolutely fine. 100%. There's nothing wrong with what you did there. I quite agree with you. So if you wanted to work with OK and OC, and then on the other side work with OE and OH, absolutely nothing wrong with that either. If there was somebody else who wanted to deduce that CK had to be 3R and then work OK, KC, OE, EH, that's also absolutely fine. No problem. But I really like what you did, Ketelwazi. So let's just put that down. Okay, so they've told us, as you rightly pointed out, what was really important here is that they pointed out that angle H and angle C were equal. All right, so if angle H equals angle C, then that means that OC equals OH. And our reason there, does anybody know?
I used equal angle, equal sides.
Okay, so the correct way to set that out, Ketelwazi, is as follows. You need to say sides, opposite, equal, angles. Okay, they are the sides, opposite, equal angles, and that's why they are equal to one another. Okay, and quite rightly so, you ended up stating as well that OE would also be equal to R. I suppose we could say OE equals OT. Where's my pen gone? Sorry, my mouse is just frozen. Hang on. Sorry, guys. Sorry, Coco, my mouse is just frozen.
Sure.
I don't know what to do now.
I think I have to wait for it because I can see it syncing. On the
Yeah, I
top
can
right
see it
hand.
syncing as well. Maybe I must just give it 2 seconds.
Yeah, it should be okay.
There we go. Let's try now. Nope. Oh, what's happened here?
Is it your
It's my, I'm just going to unplug it and plug it back in again.
okay. Is it the Wacom that's giving it?
Yes, it's the Wacom tablet. Oh, there we go.
Oh,
I don't know.
awesome.
It was obviously just having a moment. Maybe it had a bad day or something. Who
It
knows?
also needed a break. Yeah.
It obviously also just needed a break. Okay, beg your pardon, guys. Let's carry on going. So OE was equal to OH, which is equal to R, and that's because they are radii. Okay, so now that we've stated that OC and OH are equal and that OE equals OK, sorry, that's OK, equals R. All right, and now we can do exactly what you said. All right, so that means that OK over OC is going to be equal to R over 4R. Aisha, I see you asked a question.
No, ma'am, that's okay. You corrected it.
Okay. Thank you.
Okay.
Thanks for helping. And I'm really grateful because I do make mistakes. So I'm very grateful when you pointed out. Okay. And then we're going to state that OE over OH is equal to R over 4R. And again, R divided by R is 1. So that gives us a quarter. So now we may conclude that OK over OC is equal to OE over OH. Therefore, EK parallel to HC, reason, converse, proportionality, intercept. Okay, matrix, everybody happy with that?
I'm sorry, ma'am, I have a question.
Yeah, sure, go for it.
Ma'am, the way I did it, I didn't use numbers, but I used the method were given to us instead of the numbers.
Okay. So,
to get knocked down.
Well, not necessarily. When you say you didn't use numbers, did you what did you write?
Let me show you, ma'am. Wait, let me try to show you. Yes. Like this, man.
Are you going to show me what you? I don't think you can show me, but I think you can tell me.
I did. I'm showing you. Put my camera on.
Oh, okay. Hang on a second. Let me see. I can't know if I can see you. Let me just find you. There you are. Okay. Coco, can you see what Kittlwazi has written?
No, I can't. I cannot.
Yeah, Kittlwazi. I'm also struggling. Sorry, my eyesight is not the greatest. Just read it to us, Kittlwazi. So,
ma'am, I put OK is equal to OE radius. AH is equal to C, which is given. Isosceles triangle. The reason equal sides equal angles, but you corrected me there, so I'm gonna have to make that change. And then I said overall OC is equal to OH, and then I laid it out. OK over OC is equal to OE over OH.
Oh, I see what you mean now. I suppose that would probably be okay. It's obviously just we need to correct that reason that sides are opposite equal angles. I think that as long as you have, even if you didn't take it as far as what I've done here, I think that if you have shown that they are equal to the same thing, then that would be sufficient.
Yes, ma'am.
Okay, so I think that would be fine. All right, yeah, it's just the sides opposite equal angles that I would change. All right, good stuff, well done. All right, let's have a look at another example, okay? And this is something that's a little bit more unusual. Let me just make this a little bit bigger. And I need to make that a little bit bigger. There we go. Okay, so here we are given two triangles, right? And it says to us in the figure, EF is parallel to BC and FG is parallel to CD. Prove that EG is parallel to BD. Odd question, isn't it? All right, so obviously we're talking about converse proportionality intercept theorem, so it's got something to do with that. But does anybody want to make a suggestion as to our starting point? What do you think we should do here? Where do you think our starting point is?
Ma'am, I think we can say AE over EB is equal to AF over FC.
AE over EB is equal to AF over FC. And what would your reason for that be?
Lines parallel to one point of a triangle, I think.
Oh, okay, you can say that, absolutely. So line parallel to one side of triangle, or you can say proportionality intercept theorem, right? If you do say proportionality intercept theorem, you have to name the parallel lines. Okay, so EF parallel to BC, otherwise they're going to nail you with that. Okay, that's a great starting point. What's the next thing that we need to do?
We can do the same with the other triangle because they also have parallel lines. So we can say AG over GD is equal to AF over FC.
Okay, let me just make my pen a little bit thicker. Okay, so you said AG over GD is equal to AF over FC. All right, and again, you said line parallel to one side of triangle, or we say proportionality intercept theorem. It doesn't matter if we say proportionality intercept theorem, do not forget to name the parallel line. Okay, so FG parallel to CD. Cool. So now we've made these two statements. Now what? How are we going to prove? Yeah, go for it.
Okay, so therefore, AE over EB is equal to AG over GD. No?
Okay, so therefore, AE, let me just make this a little bit bigger. Therefore, AE over EB is equal to AG over GD. Good. Okay, so if two things are equal to the same thing, then they have to be equal to one another. And if AE over EB is the same as AG over GD, we are therefore able to conclude that
EG is parallel to BD.
Beautiful. And your reason? That one. Converse, well done. Converse proportionality intercept theorem. That was really good. Well done.
Thank you, Mom.
Good work. Well done. That was really nice. Okay. Matrix, how do the rest of you feel? Do you want to give us some emojis? What's going on? And you will write. Aisha, you've raised your hand. Go for it, Aisha. Do you want to ask a question?
Yeah, ma'am, the orange part. So like I get, you know, when we're just equating the sides to each other. I just don't get how we got to the AE equals to AG and yeah.
No problem. No problem, Aisha. It's a perfectly good question. All right. So, Aisha, we're working on this principle. Okay. So let me write something else on the side over here. If I was to say to you, Aisha, that quantity A was equal to quantity B, and that quantity B was equal to quantity C, and then said to you, well, what does that mean to you? What would you tell me? What conclusion could you reach? What's your conclusion?
I just see that Okay, B is what's in common. That's
Correct.
converse C. And then, can I say they're directly proportional? I don't know if that.
No, so you know what? It's even easier than that, Aisha. If A equals B and B equals C, then what this means, or the conclusion that we can reach, is that A must be equal to C. Does that make sense to you? So if A equals B and B equals C, they both have to be equal to the same thing. Okay, so they're equal to one another. That's the principle that we're working on, and that's a very common principle in geometry. All right, so often when we want to try and prove that things are equal, the idea is like often when we prove angles are equal or sides, mostly with angles really, rather than sides, but it certainly happens here with proportions, where we want to prove that they're equal. If we can prove that they're equal to the same thing, then it means that they must be equal to one another. Okay, so if quantity A equals quantity B and quantity B equals quantity C, then it means that A and C are equal. And that's exactly what happened here. Can you see that both of these proportions are equal to AF over FC?
Yes, ma'am.
Okay, so the fact that they're equal to the same thing over here means that they have to be equal to one another.
Thank you, ma'am.
Okay, it's a pleasure. It's a pleasure. All right, are there any other questions? Anybody else want to know anything? Yes, so Bopelo, it is the same thing. It's not something I generally use. Hang on a second, let's just go back here. Where was it? Hang on. So I don't know if you remember this, if you were part of our lesson when we first started proportionality intercept theorem. Okay, so if we want to work with proportionality intercept theorem, we can either say, as this sort of table over here indicates, you can either say proportionality intercept theorem, all right, and if you do that, you have to name the parallel lines. Or the other thing that you can state, all right, some teachers teach it differently. They teach their students to write line parallel to one side of triangle, but they mean the same thing. Okay, so you can use either one of those reasons. At least with line parallel to one side of triangle, you don't have to remember the parallel lines. But yeah, for some reason at my school, we all just teach proportionality intercept theorem. I don't know why we do that, but that's just the way that it is. All right, so now coming back to where we were here. So it's converse proportionality intercept theorem as the converse, or you can say line divides two sides in proportion. Okay, if you want to. All right, so either of those reasons would be acceptable. Maybe that's what your teachers are saying at school. Line divides two sides into proportion. It's exactly the same thing as converse proportionality intercept theorem. Okay, matrix. It's a pleasure, Bopelo, no problem. All right, so let's go down to where we were. We've done that one. All right, so now there's something for you guys to try. Okay, so hopefully this, I'm just going to make it a little bit bigger because I know that sometimes these things are hard to see.
Ew.
Is that okay? Can you see that now? Does it look horrible?
Yes.
Does that make you want to run away crying? Oh, I know. Sometimes you look at these things and you're like, so many lines, where do I start? Okay, so the place that you always start matrix, okay, is read the information, okay? And don't panic, okay? Because the minute you start panicking, your brain's not working properly and you can't do maths if you're not thinking logically. If you're upset or you're emotional, you just cannot do it. So you have to stay calm. All right, so now they're telling us here that P is any point on side BC of quadrilateral ABCD. Parallel, a straight line through P, parallel to AB, intersects AC at Q. So here is the point P that they are talking about. I'll just highlight it. It's down there at the bottom. all right? And they've told us that the straight line through P parallel to AB, sorry, the straight line through P parallel to BD intersects DC at R. Okay, so in other words, it goes across over here and it ends up at R over there. They have told us that this line that I've just highlighted in blue, they've told us that these two lines are parallel. So that's why I'm going to draw them in the same color, right? Normally when lines are parallel, what we do is we put arrows on them. Okay, but we don't want this diagram to be too busy, right? They've then said to us that we need to prove that QR is parallel to AD. All right, so now let's get a different color and let's highlight the lines that they want us to prove are parallel. Okay, so they want us to prove that QR, so that's this line over here, they want us to prove that that is parallel to.
Was alle cherry tomatoes?
What?
Dat kan exchange. So can exchange. Yes. Yes. When I'm done.
Sure.
Yeah, when I'm done.
There's the whole question. Can you see it okay? I'll just make it a little bit bigger. Is that's just a little bit too big. Sorry, like I'm just trying to get it in the middle of my screen, and if I do it one way, it doesn't show everything. Okay, so just color all of those. And again, can you see that okay, Matrix?
Yes, ma'am.
Okay, all right. So the line in yellow and that one in yellow, those are the ones that they want us to prove are parallel to one another. And the ones that they've given us is this one over here that's in turquoise, and this one over here that is in turquoise as well. That's all they've told us. They've told us that P is a point on quadrilateral side BC, so ABCD is a quadrilateral, and then they've told us that the line through P to R is parallel to BD, so we now need to prove that QR is parallel to AD. The important thing here is to understand which theorems they are wanting you to use in this particular case, right? So now obviously this whole lesson has been about converse proportionality intercept theorem, so that's obviously what they want us to do. But how would we know that when it wasn't this class and we were doing an exam? We would know that because converse proportionality intercept theorem is the only way that we know how to prove that lines are parallel from our metric theorems. There is nothing else that proves that lines are parallel. I mean, apart from line through midpoint parallel to second side, but that's not something that's very common. All right, so if they're asking you to prove that lines are parallel, you've got to start thinking, well, what are the things that I know that prove lines are parallel? So from grade 8, if I prove that corresponding angles are equal or alternate angles are equal or that co-interior angles are supplementary, that proves that lines are parallel. But this is not a question about angles. This is all about sides. So that's why we would discard those three, right?
Ma'am?
Then
Sorry,
yes.
Why did you highlight BD and PR in the same color?
Because they told us that those lines are parallel. That's some of the information that's come with. Okay, so they have actually said to us that these lines are parallel to one another. Okay, so we would not be able to answer that question without this information.
Oh, okay. Thank you.
Didn't they say we need to prove that QR is parallel to AD?
Yes, absolutely. That's why I highlighted it in yellow, because that's what we are trying to prove.
Okay.
Quite right. Okay, so what we're trying to prove is what we've highlighted in yellow. What we've been given has been highlighted in turquoise. Okay, so this straight line parallel to AB Is there any other information that they've given us? A straight line through P parallel to...
Yeah, there
Is
is.
parallel to AB.
So they've also told us, hang on a second, there is more information here. Sorry, I missed that. Okay, so they've also told us that the straight line through P parallel to AB intersects AC at Q. So that's also information that's given. So they've also told you that this line over here, QP, is parallel to that line over there. Okay, so that is the third piece of information here. All right, sorry, I missed that when I first read all of this. Okay, so the blue line and the orange line are the parallel lines. The ones that we've highlighted in yellow are the ones that we are trying to prove. Now, the reason why they tell you that lines are parallel to one another is because they want you to work with proportionality intercept theorem. What you should do, Ntando, do you want to go for it? Ntando, do you want to ask a question? Your hand was up. Maybe not. Okay, so what you want to do is after you have highlighted the parallel lines, then highlight the triangle that you can work in. So if AB is parallel to QP, in which triangle can I work? In triangle?
ADC.
ABC.
ADC.
Okay, if AB is parallel to QP, then it means that I am allowed to work in triangle ABC because I can apply the proportionality intercept theorem in this case. All right, because this line over here is parallel to that line over there. The other triangle that I can work in, that I can apply proportionality intercept theorem into, is triangle
DBC.
DBC. I disagree with you.
Ma'am, can we say
No. You are right. You are right. It could be DBC.
Yes,
Could be
ma'am.
DBC. Yeah.
It could be. Ma'am, it also could be ADC, right?
Yes.
ADC. It can't be ADC.
Why?
Because there is no third side parallel, all right, in ADC. So if you look at triangle ADC, which side is the third side that's parallel? There isn't one. Okay, so you can't work in ADC. Okay, so you can only work in triangles where there is a line parallel to the third side. Okay, so if you look at triangle ADC, first of all, what they've done, they haven't named this point over here, all right? So you can't say that that bit is parallel. Well, you can say that this bit is parallel to this bit, but then the third side needs to be a parallel line. That's the whole idea. Okay, so ADC is not the right triangle. So what we've highlighted in orange is correct, and what we've highlighted in blue is correct as well.
Ma'am, can I try the answer?
Go for it, Andile. What should we write, Andile? Andile, are you there?
Yes, ma'am.
Go for it.
Oh
You want
God.
to say an answer? Go for it.
Oh, okay, fine. I'll start by saying BP over PC is equal, yeah, over PC.
BP over PC, okay, is equal to?
Equals AQ over QC. AQ
I'm
over
quite happy
QC.
with that. Okay, so
Yeah,
you're working in the orange triangle,
theorem.
and you're saying BP over PC equals AQ over QC. Lovely. And what's your reason for saying that, Andile?
Prop theorem, and You use the parallel lines are PQ is parallel to AB.
Lovely.
Okay, and then the next step is BP over PC.
Just hold on, BP. Okay,
Yeah.
BP over PC is equal to?
Equals DR over RC. Now we're working in the blue triangle.
Correct.
Yeah, and that's
Correct.
prop
Good.
theorem. Prop
Good.
theorem, and BD is parallel to PR. BD is parallel to PR.
Good.
Yes. Now, since then you'll write the next step is what was the next step? Oh yeah. Therefore, BP over PC.
Mm-hmm.
No, actually, I mean, no, sorry, ma'am. Actually, I mean AQ over QC.
Mm-hmm. Mm-hmm.
AQ over QC.
AQ
Yeah,
over
therefore,
QC. Let me just
AQ
make
over
this.
QC over QC equals
Yes.
DR over RC.
Absolutely. Okay, so that is your conclusion. All right, so that
That's my
means that
conclusion. Yes.
Good. Okay, so in other words, what you've stated is that AQ over QC is equal to DR over RC. Right, and now you are working in triangle ADC. Okay,
Yes.
absolutely. Now we can apply this triangle ADC.
Yeah, therefore then QR will be parallel to AD. And that's converse prop theorem. Yeah.
Exactly.
Yeah, I think that's it.
That's quite right. That's exactly it.
So, ma'am,
Yes.
because of the two proportional interior theorem, is it because of those two proofs that AQ over QC is equal to DR over RC? Because you said we can't use the ADC triangle, so I'm just a bit confused there.
Yes, you're right. Because you see, you are trying to prove that AD is parallel to QR. So you can't work in triangle ADC. Okay, because remember, you can't use what you're trying to prove is true to prove that it's true.
Oh, okay.
Okay.
Oh,
So it's back to that whole idea again. If I'm accused of murder, the prosecuting attorney can't stand in court and say Lee is guilty of murder because she's guilty. Okay,
yes.
Lee has to be guilty of murder because her fingerprints were on the weapon, or the victim's blood was in Lee's car, or Lee was seen with the victim on camera. Do you know what I'm saying? There's got to be other reasons why Lee is guilty. Lee can't be guilty because she's guilty. Does that make sense to you?
Definitely, ma'am.
Okay.
Thank you so much.
Okay. All right. So that's just, I know it's probably not a very nice analogy to use, but I think it conveys what it is that we're trying to get across. Okay. So Tinande, this is a difficult thing to understand. So what I'm going to do is I'm going to run through it just one more time. Okay. And even if you do understand it, I think just listening to it one more time, there's not going to be anything wrong with that.
Okay, thank you, ma'am.
That's fine. Ntando, you had a question. Ntando, do you want to ask your question? I know you put your hand up twice and I just didn't get to you. No? Okay. All right. So let me just... Okay. It's all right. Ntando, I don't think you're the only person who's lost. I think there are a few people who find this particularly difficult to understand. So that's why I said I'm just going to run through it one more time. And I think it will be good for everybody just to hear this once again. Okay. So when they tell us that sides are parallel, they are giving us clues. They are actually, when they tell us that sides are parallel, they are directing us to the triangles that we can apply our proportionality intercept theorem to. All right. So they started off by telling us that side AB was parallel to side QP. So the minute they give you parallel sides, highlight the parallel sides and then draw the triangle that you can work in. Okay, so side QP is the side parallel to the third side of the triangle, which is AB, and it cuts sides BC and AC into the same proportions. Okay, then they told us, change colors now, all right, that PR was parallel to BD. So again, highlight the parallel sides. PR is the side parallel to the third side of the triangle. The third side of the triangle is BD. And now draw your triangle. Okay, so now that you've highlighted those two, you can see which triangles you can work in, right? You can apply proportionality intercept theorem in these triangles because you've got these parallel lines. And that is going to be your starting point. Do you see that line BC lies in both triangles? It is the link in this situation. It is what connects these two triangles together. All right, so where we first started off and we said, let's work in triangle ABC. In triangle ABC, we can state that BP over PC is AQ over QC because of proportionality intercept theorem. That is because AB is parallel to QP. All right. I see somebody's put their hand up. Did somebody want to ask something?
No, it's fine, ma'am. I wanted to ask, but can you finish and then I'll ask?
I'll finish and then you can ask again. All right. Now I'm going to work in the yellow triangle. So now I'm working in triangle BDC. In triangle BDC, I can say that BP, the same thing, over PC is equal to DR over RC. Again, because of proportionality intercept theorem, because BD is parallel to PR. So even if you can't prove it, matrix, at least write something down. If you know that this is true, at least write it down, because you know what? You might not get 5 out of 5, but at least you can get 2 out of 5 or 3 out of 5. Okay, so it's better than nothing, right? That's why it's better to try and write a little bit of information down than just leave something completely blank. If something's left blank, no one can give you any marks for it. Right. So now you make these two statements and you sit back and you look at your information that you've written and you say to yourself, well, hang on a second. What do I have in common here? What belongs to both? All right. Can you see you've got BP over PC over here and you've got BP over PC over here? So if both of these quantities on the right are equal to BP over PC, they must be equal to one another. All right, so that's why we would then conclude that AQ over QC must be equal to DR over RC. Right. Now, what does that mean for us? If AQ over QC, now look at this, all right, let's highlight this triangle. All right, let's use a different color. Let's go with pink, okay? So if AQ over QC equals DR over RC, those sides are in the same proportion, okay? AQ over QC is the same proportion as DR over RC. Therefore, we are able to conclude that line QR must be parallel to line AD. All right, so now you're working in triangle ADC. Okay, so this over here, not that we would write this, you are now working in triangle ADC. Right, so the conclusion is that therefore QR is parallel to AD, reason, converse, proportionality, intercept theorem. Okay, one person did ask me how many marks this could be out of. If they gave you a mark for the proportion and the reason and the proportion and the reason and the statement and the reason, it could be out of as much as 6. But I'm not sure that you would actually get something like this out of 6 marks. Okay, so now there were a few questions that I think people wanted to ask.
Yes, ma'am.
Go for it, Loyiso.
I wanted to ask, ma'am, would it be marked wrong if in the exam, and you know, ma'am, when you're writing an exam and your head is buzzing, so what you do is you take BP over PC is equal to RQ over QC, and then as your conclusion, you write BP over PC is equal to RQ over QC is equal to DR over RC. You write all 3 of the sides down, and you put BP in the middle because it's common in both, and then you take another step down. Then you say AQ over QC is equal to DR over RC.
Okay, all right. So let's just go back to what it is that you said. Your starting thing was to say that BP over PC was equal to
RQ over QC.
RQ over QC. Now just hang on a second. So you said BP over PC was equal to RQ over QC. No, you see now this would be an invalid statement. Right. And the reason that this would be an invalid statement, unfortunately, Loyiso, is because you're not working inside a triangle. You're just taking random sides and saying that they're equal to one another. Okay, so because what you're doing here is you're working, there's BP, there's PC. RQ is here and QC is there. Do those lines that I've just highlighted, does that make a triangle?
No, ma'am.
It doesn't. Okay, so what you've done is you've taken different line segments and you've made them equal to one another. So what you've got to look for, Loyiso, is you've got to look for the parallel lines, right? The parallel line must be, the one parallel line has got to be parallel to the third side of the triangle, and then you need to draw your triangle. All right, so that is always the best way to start. Find the parallel lines, highlight the triangle that they lie in. If there's another triangle, find the parallel lines, highlight that triangle. Then you know which triangles you can work in and you can make proportions. Okay, so unfortunately, because your argument was based on an invalid statement, you wouldn't get any marks for that. Sorry, Loyiso. I hope you at least understand why. You think he meant AQ?
Yeah, I think what he meant was
if he meant AQ, then that's totally different, isn't it?
AQ, ma'am, that's what I meant. Sorry.
Yeah, he meant if you write BP over PC equals AQ over QC equals DR over RC. I think that's what he means.
Oh, is that what he's trying to say? Equals DR over RC. Let me just write this down. Equals DR over RC. So BP over PC equals AQ over QC equals DR over RC. When did you write this? Did you write it after we had done this step here and this step here? Or was that what you started off by saying?
No, I first proved the two, ma'am. I first proved the two, and then you write this step down before you come down to your conclusion.
100%. Sorry, Loyiso, nothing wrong with what you've done. I understand now. Andile, thanks for helping. I'm sorry I misunderstood you. So nothing wrong with that. That's perfect, perfect. Is there anybody else who wants to ask a question?
I think Kanyisile's had her hand up for a while.
Okay, sorry, Kanyisile, go for it.
Ma'am, since we say that triangle ADC, we don't work on it, does that mean if I had to say CR over RD is equals to CP over PP, and CR over RD is equals to CQ over QA, therefore CP over PP is equals to CQ over QA, would that be wrong?
Okay, let me just, I have to write down what you're saying, because then I can analyze it properly. Okay, so just say that to me again, my girl, and then I'll write it down here. Okay, so you said that?
CR
over RD
is equals to CP over PP.
Over PB. All right, so now if you say that CR over RD is equal to, that's fine because you're working, okay, so that would be okay, that would be fine. Yes, carry on.
And then CR over RD is equals to CQ over QA. Therefore, CP over PP is equals to CQ over QA. And then we say QR is parallel to AD.
All right, now, when you said, I'm just going to go back to this middle statement over here. All right, so this statement here, oh gosh, we don't want that. Sorry, that's a bit dark. Okay, so this statement over here, where you've said that CR over RD is equal to CQ over QA, that is where your problem is, all right? Because this triangle over here, we don't know that these lines are parallel. So if we don't know that these lines are parallel, we can't state that this over this equals this over this. All right, so that's where the problem lies with what you've said over here. This is what you're trying to prove is true.
Oh, okay.
That's what you're trying to prove is true. Okay, so you can't use it as a reason to prove that it's true. All right, that's what the issue was. Okay, so here you would, if you had put your reason and your parallel lines, then that was fine. You could have got marks for that. But then anything based on this statement over here that isn't correct, you would have then lost marks for, unfortunately.
Okay. So, ma'am, in place of that, what would we put? In place of CR over RD is equals to CQ over QA, what would we use?
So what you should have done is you should have said what I had said in pink and green and blue.
Oh,
okay. So exactly what's on the screen here. All right.
Okay, thank you, ma'am.
It's a pleasure, Kanisile. Oh, Matrix, I'm so sorry. Our time is up. It always goes by so quickly. I wish we could spend 2 hours together. There's always so much for us to discuss and talk about, but we'll see you again on Thursday, and have a really good week. And yeah, we'll see you then. Bye, everyone.
Guys, remember Thursday. Thank you, Thursday is quiz day, so we'll see you guys on Thursday.
Bye, ma'am. Thank you.
Bye.
Pleasure.
Bye.
The video will be up on our website in the next couple of days. So it should be either tomorrow or the day after. Thanks so much for joining us on Duduzi. Hope to see you on Thursday.
Pleasure, Duduzi. Hope you found it useful.
Thank you. Bye.